And today our topic is object-oriented thinking. So we will talk today about classes and objects, about some ideas behind, and also we will discuss how it works in Java, which syntaxes we have for that, and so on and so forth. So let's start with the definition of what is class, what is an object. So talking about class, we can think about it as an abstraction of like a real world entity. So like we have like car, it's an abstraction because when we say car, we usually like imply like general car, not a particular car. But if we like say I see that car, a blue one, for example, and we meaning like a particular car, which is an object of a car that has like specific characteristics, year it was produced, like type, brand, like, and so on and so forth. So class, it's a template object, it's an instance of a class with specific parameters, or we can define its class recursively, like we can say that class it's something that describe similar objects of real world. So we can give class definition like through the object term, and we can define an object as an instance of a class. So I hope it is clear for now, and we can continue. So in Java, class is defined this way. So we have a keyword class for that, and then name of the class is followed. So we also have so-called access modifiers, which is public and private. So we talk about them a bit later, but private means like no one externally can access this field. It can be accessible only within this class, and public means it's accessible everywhere. And I will explain why a bit later. So we have constructor. It can has no parameters. That is called default constructor, and we can have a constructor with parameters. So if you don't define any constructors, it means there is one constructor, a default one, defined. So if you don't define any, will be like implicitly the default constructor will be defined. What it means constructor, it's like method, we may think of a function that creates an object of this class. So, and we also can define a class as a combination of attributes and methods or functions. So we can like provide like different definition for a class like from different points of view. Okay, so how we do create classes? We are using like keyword new. And calling constructor, passing parameters to the constructor to initialize our attributes or fields in the class and passing the specific values. At this moment memory is allocated, and like this variable of reference type is referring to that object in memory. So what else? We also can model entities of a real world, like for this we can use like inheritance, so-called inheritance. So our abstractions can be inherited one from other. So like we can have an abstract library user. It's like kind of ultimate abstraction, but it's not probably enough like to understand which kind of user is it. So we can call this class abstract class. And like we can have more specific classes like readers or librarian that like has additional attributes to this class. So like inheritance like mostly meaningful when you add some attributes or some behavior. So behavior means methods. And you can like have different level of abstractions, more specific objects, and so on and so forth. And Java do not support multiple inheritance. You can only inherit one class, but you can implement multiple interfaces. And what is an okay? I will talk about interfaces probably a bit later. What is inheritance? How it's implemented in Java? It's implemented using keyword extend. So we have some attributes in like a parent object, and this object will be called parent, and this object will be called child. So, and we say one extends car, and it has all attributes that car has, but additionally it adds one more attribute, which is load capacity. And you also specify construction, but to like bypass arguments to the parent class, you use keyword super, which calls constructor of superclass, which is car. It's also like another alias for parent class. It's can be called superclass, and you pass arguments to the constructor of parent class. So this will be called, and then you initialize property of this class, and you also want to add some additional behavior. So when you create something, when you extend something, you add something additionally. And the inheritance is read like reader is a library user. So when you read some diagrams like that, you can use word is, because reader is a library reader that has all attributes that has library, but adds some more attributes. But like opposite statement is not true. Library user is not always a reader. It could be also a librarian. So that's why we can like we can assign a reader to reference of library user, but opposite assignment is not possible. What else? There is also a special type of class. I mean, not of class. It's just idea, like that. Sometimes, I mean, it's considered to be more safe if your class is immutable. It means you can never change it. It's also this concept is more closer to real world scenario. Like after you create a class, you could not change its state. So you don't have setters, and all your attributes final. It means you cannot modify it. And if you have it before attribute, if you have it before class, it means you could not inherit this class as well. So immutable class, it's like it's not like a special keyword. It's just an idea that you can create class that is not modifiable. And sometimes if you create class, it's better to create it's immutable and only add setters when you need them. But it's more probably like more advanced topic. And when you create classes in your homework, probably you can create them like with getters and setters. And we will talk about getters and setters a bit later, why we need them. Okay. In Java, there is a special type of a class that called Enum. This class, it's a user type that can define a finite number of particular states. So, for example, in Java, you have different data types. For example, you have Boolean, int, and so on and so forth. But sometimes these types not always enough to model like real world. For example, Boolean has 2 states, but if you need 4 states, probably it is not the best idea to use like integer for that, because integer has much more states than 4. So you can create a special class called enum using keywords enum and define your states. So it will be a type of 4 states in this case. So we can think of a class. It's also kind of user-defined type, data type, or structure. And if we model like enum with just class, it says you have a class that has only 4 objects, and you could not create more objects because constructor is usually private. Private, it means it's not accessible outside the class. But for that, you have enum. Okay, let's go next. What else we should know about classes and object-oriented programming? So we have like 3 basic concepts. It is inheritance, encapsulation, and polymorphism. So we talk a bit about inheritance. Let's talk about now a bit more about encapsulation. Encapsulation means when you hide details of your implementation from you hide it from external world, from external access, and this allow you to simplify your code. So in order not to expose additional complexity, you only expose like interface of your class. Interface means like public methods or behavior, and by this it's make your code easy to understand. It's more safe to modify. So last time we talked that maintainability, it is important. So when you have encapsulation, when you like hide details of your implementation inside the class, it's called encapsulation. And for that, you have 4 types of modifiers. Like private keyword means it's not it's accessible only inside this class. Public means it's accessible from elsewhere. Protected means it is accessible from the class and from the inherited in the inherited classes. And package private access means when you specify no keywords, it's accessible within your Java package. So probably it's not like the best practice when you don't specify a keyword. If you like write no modifiers, you should have a reason for that. So if you need access only inside your package, or for some reasons you need access inside your package, you need to explain why. So always try to put modifier to your attributes or methods of a class. So by default with attributes we go to private because we're trying to hide everything from the external world. And for the method and probably classes, by default we usually go with public. But there can be exception, like private methods also possible. So if there is just utility methods that like do some work, but you don't want to like expose them outside. So it's not a private method. It's not like main method of a class, but public methods is kind of defines the behavior of a class. And protected word, I would say it's also like rarely used. So even there is no for the attributes, there is should not be much reasons to make the attribute protected. It's better to have it private and like expose protected method to access it, because you also need to hide your like details of your implementation from child classes as well, in order to better manage the complexity of your code and access of your data. So this picture, I think, illustrates encapsulation well. So like you only have small number of things that's exposed externally, but you have much more inside, but it's not exposed, it's not accessible. So this is encapsulation. How it looks like? It looks like this. It has a private attribute, and it has getters. No, we don't have getters, but we could have getters, but now I just have setters. Getters and setters, like they are public and they allow you to access your field like through the method. Why we need that? Why we cannot just make it public? Because if you would like to change like later the type of your attribute, if you change it, your all like other classes that was using this field directly, you need to like make changes in in all classes that were using this class and this attributes directly. But when you make it private and only expose public methods to access your variable, your attribute, you have a better control on your implementation and on your data. So, for example, today we have these characters and this method. But tomorrow we decided like to change it to string, for example. And like this, okay, no, let's say we had like this, like letters. And then tomorrow we decided to change it to chars. So the the other classes that were using this class, you don't need to change them. You can just change it internally, right, to make something like this. And for new like usage, you can also provide additional interface that does like that. So the thing with this approach, you control everything inside this class. You don't need to change other classes if you change this one. So that's why it's safe and it has better control when you have it private, when it is encapsulated. Okay, is it clear? Is everything clear so far? Maybe any questions? Okay, if everything clear, we go next. Next topic is polymorphism. This picture also illustrates, I think, the meaning of polymorphism. So you can have like one abstraction, one like meaning, like you have pattern. It does same things, but implementation is a bit different. You have different buttons, but you can manage them like as similar objects. And you can use it like in similar way, but implementation could be different. So let's go with the example. So you can have an interface. Interface is an abstract class that has no attributes and it's only have like a contract. It means like you don't have even like implemented behavior. You specify only which fields which methods you will have in the interface. So you just specify the behavior, the contract of your class. And other classes implement the specific behavior. So you say you have a class, it implements calculator, and you define behavior in a certain way. So we can have a multiplication calculator that like multiply your numbers, and we can have other implementation that like calculate the sum of your numbers. So two different implementation, but they still have same interface. What else? Overriding over. Okay. And then you actually like it's not important for you which implementation you have. You just work with this interface, and you call and calculate, and you not thinking much about like which implementation you have underlined. So this is polymorphism. So it does not important for you which implementation you have. You work with interface and you get in your behavior. Like you can use them in the same way. Even you can like put them into a into collection, for example, of calculators. Let's call it quick calcs. And you can say like arrays as a list, and you can put this to implementation. Here they have one interface, so the reference is defined as an interface, and you can just iterate over your collection and call calculate for each for each service, and you will have different behavior, but you interact. Sorry, stream. You interact with this like with you can just print it, right? It's not Java, but just let's say we have method print. So you can sorry, what I said. No, you can just make x calculate and you pass your arguments like 1 and 2, and depending on the implementation, like different behavior will be like called. So it's not important which kind of implementation you have. You just interact with them as with interface, and depending on the interface, you are getting different behavior. So it's polymorphism. Okay. What else we can have? We it was polymorphism. Polymorphism when you have like same names of the methods but different implementation. But there is additional concept called overloading. When you have you don't need inheritance for that. You just have one class, and having one class, you just have two methods of the same name, but they accept different arguments, or one of them accept no argument, on other one accept double. So you overload the method, and you can call a method without parameters and with parameters. So when you have two methods of the same name but different arguments, it's called overloading. Okay, what else we have in classes? And by the way, probably I forgot to notice that there is a special keyword called this. You referring to an object of this class using keyword this. So you're referring to an object of this class. Inside this class, for this you need this keyword, because like if you have same names of the variables, you need to differentiate this variable from this variable. To do that, you use keyword this. Okay. Next topic is static methods. As you may remember, like main method is static. What static means? So like if method is not static, it belongs to an object of a class. So or if a field is not static, variable is not static, it belongs like to object. But if you have like static field or static methods, it belongs to a class itself, not to an object. So you have only single like a method, and it's called by class name, not by object reference. So when you have like a static method, you cannot use this super. It's bind early. It means like it binds in compile time, not in a runtime time. You cannot interact with non-static blocks because, like, if you want, if your main is static, you can also call only static methods, like, and you could not override static methods because they belongs to class, not to an object, so you could not use polymorphism for them. So when we can use static methods, so in general, I would recommend you to avoid using static method except of main method, because static is more of a procedural programming rather than object-oriented programming. So it's, as you remember from the last class, like procedural programming was invented in the 16th of last century, like with the top-down approach, so on and so forth. It's still like a useful concept, but when we like use a lots of like static methods, we don't use like power of object-oriented thing, and our code becomes more complex, more harder to understand and to maintain. So it's also hardly testable. As you remember, we talk about testability, unit testing, and so on. So try to avoid it in general. Don't like use static methods if you like don't need them exactly. So is the only thing that I can recommend for static is like static fields, actually constants. So you don't, if you have a constant, you don't want to have it like instantiated in every class. It can belong to it shouldn't be instantiated in every object. It can belong to a class because like all your class, all your object will share this constant because it's like something that would not change, and we need only one instance of such constant. So for the constant, you can use static. You should use static and final. So it means like you will never change it, and you need only one instance. And for the constants, you remember we have different naming. So, and magic numbers is not good. So we should not use like this inside our code, because if we don't have this, actually it's hard to understand what does it mean. But when you have a constant, it's like your code becomes self-documenting. You don't need any comments. You just document it like using naming. So, and the static methods are called by not an object name, but it's called by a class name. Okay, what else we can tell about static? You can have like static block in initialization, like you may have a constructor, and you can have a static block that like runs before your constructor, and you can you can initialization blocks that run before your construction, but if it's static, it's run not in the construction time, but when your program starts, when all classes loaded. So you can like there is such option in Java, so you can to initialize your static variable or do something once, you can use like static blocks. But I would not, I mean, there is a technical opportunity to do that, but I would not recommend doing that because like it's not like easy to understand. If we have some initialization, it's like a bit misleading, and if you could avoid it, you should avoid it. So use like a general approach, like constructor, like and so on. Okay. Okay, we don't have much time left. I will speed up a bit. So all classes in Java implicitly inherited from an object class. So when you define your own class, it's implicitly extends object class, and you inherit all like attributes, all methods from the object class, and by default it has some. So it has hash code method, which returns you unique code, a hash that like describe your object, yes, that describe your object uniquely, and has also a method like equals to compare you to your objects and by default it is compared by reference. So you may know that there is like there is a reference type in Java. So when you create an object, you have a reference to this object that in memory takes only 4 bytes or 8 bytes. But the object itself is located in heap. So by default is compared not by values that class has. By default it is compared by reference. So the two objects are equal if they referring to the same memory. So but if you want to compare them by value, you need to override it's polymorphism. We talk about this in polymorphism. You need to override this method in your inheritance. So you will re-implement this method in your child class to override the behavior. And you also have toString methods that by default prints name of the class and hash code. So and you have also some methods like clone and so on. So these two methods probably most important that you need to know. So when you define your class, it's it's usually a good idea to override to redefine the behavior of this default method to compare your object by their values, not by reference. And there is some specific rules how you need to define it. So you check if it's not reference to itself. Yeah, so you compare it by reference first, and then you compare that they have the same class, get class. It's returns the class object from which class this object was created, and if they are the same, you cast the object to this type, and then you can access attributes. So we can access them directly without calling get field, because it is inside this class, and we can access them directly. So, and there is some logic also behind the hash code. There is some helper methods, which is actually static, because yes, it is utility methods that calculate a hash code. Usually it's take some prime number, multiply to your value, and it adds it. So it's try to describe your state of your object in one integer. So if you have two object has same attribute values, it will have the same hash code. I'll just say code for simplicity, right? They will be represented by the same number. If like objects are similar, it means they referenced to different like memory, but they have the same values, and they should return the same hash code. Also, if you have different objects, I mean they're different by values, they should return the different hash codes. But sometimes collision may happen, so the algorithm of the hash code is not like ideal, and sometimes different values may return the same hash code, because like integer has finite number of states. It's 2 power 30 in power of 32. So you have finite states, but the combination of the values like more than that number. So that's why you could have a collision. So if your hash code is equal, it does not mean that the object equals itself, but the vice versa. If object equals, so they should have the same hash code. And when you overwrite equals method, the equals method should follow. I mean, the how your equals method works. It should comply with these rules. So x should be equal to x. So a reflexive rule. So if x equal to y, then y equals to x. And then there is other rules. So it should be transitive, consistent. And if you compare any object to a null, it should be always false. Return always false. Null, it means like you reference reference to nothing, to object was not created yet. So null reference, no memory is referenced. So, and I would recommend you to do some homework to practice topics that we talk today with you. So I would recommend you to pick up some topics that that are listed on the other slide. But here is example of a task. So let's say you have candies, and you want to create a like Christmas present or Christmas gift, and you need to describe the hierarchy of a candies. Means like you need to have like classes, child classes, and so on and so forth with attributes, and you also need to collect a child's gift and determine its weight. So let's so is this how your like classes may look like? So it's called UML diagram. So you have a class which is abstract suite. You have two attributes. Minus means private, two private attributes, and you have some inheritant that like inherit your abstract, your class. You add more attributes. In this case, it could be enums, because like chocolate type is finite. Like you can have dark, milk, and white, for example. And you have some gift that contains like number list of like your sweets. And here on this slide, you see different topics. Maybe you want to screenshot them for now, but later the recording will be passed to you. I will showcase now how to quickly how to do this task. Probably it will take 10 more minutes. But before doing that, so you may be also interested in some materials that like some useful books that I could probably recommend you to read selected chapters on object-oriented thinking. You may also read them here. And in general, it's a good book when you start learning Java and start learning object-oriented programming. And there is some also like articles that may be useful to you. I think these materials, this presentation is located in MJC GitHub repository in the module in folder that's called extra, and you will find this presentation with all these materials and so on and so forth. So now let's quickly create a project. I will just showcase quickly how to do that. Let's call it give. I would create Maven. So I would also recommend to use Maven. If you missing new project, Maven give. I would also recommend to use Maven if you like aware of it. So if you're not, you can just create a simple Java project. So, and here I quickly create package that will be new package MJC gift. Then I quickly create class called suite. We can make it abstract. Sorry. Then we create a very field of string. Let's say it has name and it has a weight of, let's say, double. And then we can quickly generate constructor. We can quickly generate getters and setters. And we can quickly generate equals and hash code if you need. Let's see what we have here. It's generated for you, and also like hash code. There is an algorithm how hash code is calculated. And you may also learn from that, but yeah, probably I would recommend to implement equals on your own, at least for the first time, but then you can generate it. So you also want like chocolate suite that has that extends like suite, or I should call it abstract suite, because like there is naming convention to call abstract classes from abstract word, and then I will quickly add enum. It will be enum that called chocolate type. Let's have it milk, black, or dark, dark and white. And then I quickly create private chocolate type. Let's say chocolate type. Quickly generate constructor. Called super. Quickly generate the rest stuff. And quickly generate hash code stuff. And it calls also super to calculate hash code. Then I quickly create my calculator class, calculator that, oh, sorry. I also want to create gift class that has a list of abstract sweets, right? It will be my array list. And then probably I would like to have method add abstract sweet, and probably I would like to create here an array list. Then I this sweets add sweet, right? Then I need getter, I think. Getter, probably no setter. And inside my calculator, I create method that returns double to me. Calculate weight. Will accept gift. So now I don't need to pass three parameters here. I just pass in the entire object and have abstract sweets, gifts, get sweets, and I can probably quickly map x get weight. Then I have some. Do I have? I think I have reduce. What do I have? Reparation. Don't remember exactly how to reduce it. But never mind. Let's we return it. A double. And then what I want to do, I want to have a main class. Public static void main. Then I create like chocolate sweet, new chocolate sweet, instantiate it with some values. Like, let's be quick. Add chocolate type, let's say milk. Then I create gift. So I created calculator in a separate class. Yeah, because it's better to split your actions by different classes to have like clear responsibility, but it's a bit like different topic. But for now, I would just recommend you to do it by example. Calculator, and then you calculate weight, gift, double weight, and then you can print it. Something like that. I just model it one element, one created one subclass. In homework, you just need to create more, and you need to choose different topic. And it's also good to have different packages so that you can put your entities in one package, and like some in your logic you can put in like a different package. Something like that. Probably that's it for today. Do you have any questions for now? Any comments? Is something unclear? Guys, can you hear me at least?
Yes.
Okay. I hope it was a difference between abstract class and interface. So abstract class can have fields and can have methods implementation. So abstract class is a class, like a regular class, but some of methods may not be implemented because you don't know yet how to implement them. And if a class has an abstract method which is not implemented, you should define this class as abstract. So the meaning is mostly like logical. So interface specify only behavior. It could not have any implementation on or any fields. But abstract class is like more like a regular class, but it's a bit abstract to like create a specific object. In Java 8, as an interface, you can specify the default implementation of the method, but it's like a bit different topic, and there is some reasoning for that, but I would not touch it. But let's say interface define a contract of a class, abstract class define an abstract implementation of a class. That's it. Any other questions? Great. So I will stop the recording and have a great day.